In this lesson, we will derive the common approximation, 8 inches per mile squared, for the drop due to Earth's curvature. We will start from a clean geometric diagram, write the exact drop height equation, and then simplify it using a small angle approximation and unit conversion. Let's build the picture. We will model Earth as a circle of radius capital R. An observer stands at the top point, and we draw the tangent line at that point. Now, move a short distance along the surface to a distant point. The vertical gap up to the tangent line is the drop, which we will call h. We will label the arc distance as d miles, the central angle as theta, and the radius as capital R. Here is the exact drop height equation from circle geometry. First, in terms of the central angle, the drop equals r times 1 minus cosine theta. That is, h equals r times open parenthesis 1 minus cosine theta close parenthesis. Equivalently, using a right triangle to the tangent line, h equals r minus the square root of r squared minus x squared, where x is the horizontal offset to the point. The arc distance d along the surface relates to the angle theta by d equals r times theta, so theta equals d over r. For small angles, the cosine of theta is well approximated by 1 minus theta squared over 2. Substituting this into the exact formula gives h approximately r times open parenthesis 1 minus open bracket 1 minus theta squared over 2 close bracket close parenthesis, which simplifies to r times theta squared over 2. Replacing theta by d over r yields the very useful approximation h is approximately d squared divided by 2r. Now for the 8 inches per mile squared. Take Earth's radius, r, as 3,960 miles. In this formula, if d is in miles, then h comes out in miles. To convert h from miles to inches, multiply by 63,360 inches per mile. So h in inches is approximately d squared divided by 2r times 63,360. Plugging r equals 3,960 gives 63,360 divided by 2 times 3,960, which equals 8 exactly. Therefore, h in inches is approximately 8 times d squared, with d measured in miles. To recap visually, the drop h is the small vertical gap between the curved surface and the tangent line at the observer, 4 short distances compared to Earth's radius. H is very well approximated by d squared over 2r, which becomes 8 inches times miles squared after unit conversion. The 8 inches per mile squared rule is an approximation. It assumes the distance is small compared to Earth's radius, and it measures drop relative to the tangent line at the observer. For larger distances, use the exact circle formulas.